Hi, I'm Alexandra and I turn old technology into something new and usable in our modern world. Now, we are currently working on the engineer's laptop, and last time we stopped where we went to the machine shop and made the screen fit like a glove. Well, it works, and I cannot exactly divulge how because that is for our next section of the software. But today we're going to look at the hardware and how exactly the keyboard interfaces with the screen. But before we continue, it is important to note that we have some considerations. Number one, time frame. I originally aimed to get this thing ready and working as a daily driver for the first day of university. Well, orientation week has started. The next consideration is obviously my skills. And sometimes I have to cut corners. So join me as we fit the screen and find out what's really going on inside.
So what exactly are we putting inside? How does it interface with the screen? What are the considerations? Well, simply, directly connecting to the screen would be awesome. That way we can use the tablet's internal computer and we're set to go. We could use Termux on the tablet and then connecting our peripherals with Bluetooth will be easy. It did work. Like a bomb. But it didn't quite fit the design philosophy of making it look and function as authentic. This gives us an opportunity between a trade-off. We can Bluetoothify the keyboard, which would be great, but the time frame directs me to something that I'm actually confident will work by using something I already have. And to be fair, it is a step in the right direction to Bluetoothify this keyboard in the future. Yes, you got it, a Raspberry Pi. I have two more begging to be used before I buy anything new. A Raspberry Pi is a pretty standard system on a chip computer board. It has Wi-Fi, Bluetooth, and tons of support right off the bat. In our specific situation, I have a Pi 3B version 1.2, but what I do know is the RAM that I'll have free in idle will be more than what this laptop had in both storage and RAM the day it was shipped. Our model of the LTE Lite had 2 megabytes of RAM and 84 megabytes hard drive space. This has 1 gigabyte of RAM. By any measure, this is a significant upgrade. Considering modern hardware specs, it might seem a bit limiting. So now we are using a 32 gigabyte SD card. Considering it where it comes from, we just upgraded the RAM by over 50,000% and the hard drive about 38,819.05%. So considering raw compute power, we are now comparing our quad-core ARM processor with an Intel 386 SL. The Intel 386 SL was released in the early 1990s. It had a clock speed ranging from 20 MHz to 25 MHz. It had limited performance, suitable for basic computing tasks of its time. The Broadcom BCM2837 processor in the Raspberry Pi features a quad-core ARM Cortex-A53 CPU. This runs at 1.2 GHz. It offers significantly better performance compared to the Intel 386 SL, especially for modern computing tasks and multimedia applications. In summary, the Pi 3 Model B version 1.2 offers significantly higher performance, modern features, and versatility compared to the Intel 386 SL processor. Now, my dream is to build better and better computers into all chassis. I really like to think of myself as one day putting an M-series Mac into the original PowerBook, or even better, the Macintosh Portable, or even a clamshell, just for the heck of it. Let's move away from the technical hardware. And that's it. That's the video. Kidding. The main success or failure of this project is pivoting on getting the keyboard to work. And from here on, this video is basically the best of the keyboard attempts, failures, breaks, abuses, and, well, success?
Yeah, right.
Getting this keyboard to work requires us to connect this 30-pin FBC cable. Oh, it's a fancy technical name for this ribbon with little thingies on them. I opened up this keyboard just to have a look, hoping that a bit of brain can solve it before we head into programming. But nah, brain could not compute. To find out what everything does, we need to write a smart program to figure this out for us. This video, we're going to focus on some of the ground fundamentals on how we can interface between the keyboard and the Pi. My first sadly destructive and irreversible damage I'm doing to the actual PCB is about to commence. Although this part of the process is seriously heart-crushing and soul-wrenching, I had to desolder the original connector from the computer board. And sad to say, it did not go well. For starters, the camera cannot catch what atrocities I had to commit. And secondly, I ended up using excessive force, crude weapons, and psychotic drive to remove this fitting. So allow me to introduce this fitting. This fitting have two staggered sides of 15 pins each, spaced 2 millimeters apart. Or if you count them, 30 pins spaced 1 millimeter apart. So you think we can just use a prototype board and that will be the end of it? Sadly, it didn't fit well. So instead of that, I spent some time to get it ready and solder these jumper cables directly to these tiny pins. Now, it is a good time to mention that soldering these things together is not a job for everybody, especially in South Africa, where you can be met with a mandatory timeout at any time. Thanks, Uncle Cyril. So here you have it. The perfect soldering skills on display. I think sometimes my photography makes it look way easier than it was. Until you blow this into perspective, that there are about 25 pins in 1 inch. That is 10 pins per centimeter, 1 pin per millimeter. So we plug it in, and sooner rather than later, the software identified which traces does what. That said, software quickly turned into something that can actually concretely prove that there is no physical problem with this keyboard. This is our hardware section though, and we have to admit about the fragile nature of our current connections. Just with a bit of movement, some of the traces gets disconnected, even to such extent that I eventually moved the soldering iron from the workshop to my computer. Now this new arrangement seems like a smorgasbord of a mess, and it was. But resoldering the loose pins, even after a couple of times, is not only more difficult, it also requires removing the other pins out of the way, which creates more liability. So then I had a great idea. In them olden days, the old technology actually had a bit of glue gun glue to keep it all together. So after securing all the pins for like the 6th or 6 millionth time, I wagered what a nice idea. It worked. I put the glue on and all my problems were solved.
Yeah, right.
Software and hardware cooperating perfectly, giving all the right feedback. Now we can move forward to fitting everything together, finding permanent residence for our electronics inside of the computer chassis, and addressing the issue of power. For that, we have this 20,000 milliamp hour power bank. The electronics inside is everything we need, but there is one issue. The flaw in the system is that the output of the battery bank is cut as soon as the power bank is charging. This means this laptop is the exact opposite of many of its peers now, and probably your laptop too. Older laptops, batteries tend to fail, and then they can only work when they are connected to power. Our laptop can only work when it's unconnected. This adds to the charm, and resetting the Pi now requires a quick connection to power. So with everything in and working, the next step is assembly, right? Right? So you remember our previous successful glue bead? It needs to be redone. Now I will have to undo all the hard work, the glue bead, undo all the solder, redo all of the solder, And sadly, this was not caught on camera. I am pretty sure I recorded it, but I'm not going to own up or admit it to my technical disabilities. Our new breakout converts a 30-pin side connect 1mm pitch FPC connector into a 30-pin double row 2.54mm male header. This could now easily be connected to the Pi, and the 2 pins that are blank on the FPC, well, they can simply be left unconnected. I am putting this clip on repeat because it is simply the most beautiful thing I have ever created. I drilled some extra holes into the prototype board to have it spaced perfectly with the original screws of the computer. And this worked perfectly. Obviously not. But after I re-drilled them, this was adequate to put everything back together. So connecting everything up means we'll have a complete laptop that just works.
All of this just works. It's not, I'm not kidding.
Yes, I am.
And again, it just works.
Yes, I am.
All of this just works.
I don't think so.
All of this just works.
Oh, yes, it is.
Just works.
No, I'm not. Shut up.
So obviously it works. But I can't show you, because for that we'll need to understand the operating system and the software. I've been Alexandra, and I turn old technology into something new and usable in our modern world.